Yeah. So hello guys, today we are going to solve the question of the question problem of the day. So question says number of steps to reduce the binary number in binary representation to 1. So basically we have a given number. Let's say our number is 1101. Okay. So our number is 1101. So it says two conditions. If the number is odd, then we add 1 to the number, and if the number is even, we just divide it by 2. So here you can see this is nothing but 13, right? So this is odd. So when we add 1 to it, it will become like this. Yeah, it will become 14. So when I in first step I got 14, and this in this situation what we will do, we divide this number by 2. So this is basically 14. So when we divide it, so it will become like 7, and 7 will be 111. Okay, and this is become uh, odd number. Again, what we will do, we add 1 to it, so it will become 8, something like this, right? It will become 8. Now again it will be, uh, it is a basically even number, right? It is a even number. So what we will do, we divide it by 2, so it will become 4. Again it is a even number. Now we were going to divide it by 2, so it will become 2. And now again this is even, so again we divide, so it will become 1. So you can see this is when we reach at the 1, we have to stop. So let's count how many steps we have taken. One step to add this one, then divide, then divide and divide, then we got 1. So what we are doing here, main thing is how we determine the number is odd or even. So if the last bit is 1, then we can say it is a odd number, right? And if last bit is even, we can say it is a even number. So you can see here this is a last bit is odd. Uh, that is 1. That is this. It is a odd number. This is zeros. This is a even number. 0 even, 0 even. And when we get this, then I have to stop. So how to solve this question? First thing, what we will do. So uh, let's say we have 111, and this is odd. So we have to add 1. So when we add this one, it will become 0 0 0 1. Means and in this situation we got even. So what we will do here, we know we have a given string. So first thing we will reverse it to make why I'm reversing this string, to make we can easily solve this when I reverse this. So what we will do, let's see, just consider this example, the previous example 0 0 1 1 1 0 0 1. So when I reverse it, it will look like 1 0 1 1. Now we are traversing from this side, right? We are traversing from this side. So here we got 1. We got 1. So what when we got 1, that is this is the odd number. So we have to add 1. So what we will do? We are going to add odd number to this. So we have the number 1011 1, and when we add 1, it will become 0. It will become 1 1 1. Okay. So every time when I am going to add, when I got a first bit here, it is a 1, then I am going to add 1 to it. So when I add, now our number looks like 0 1 and 1. So one step I have taken, I have added 1. So this time we were at index 0. So now we had 0, that means we can divide it by 1. So what we will do, when I got 0, increase our pointer to the next element and increase our counter as well. So first I added 1, so for that I have increased, that is 0 to 1, and this time I got 0. So again I am going to increase our pointer to counter to 2. Now, now we have string. Now this. So just consider this part. Consider this part only. We have 1 1 1. Again, I got the first bit as a 1. So I'm going to add 1. So when uh, I'm sorry, it's my bad. So this time I'm going to add 1. So it looks like 0, 0, 0, 1, right? So it look like, right, let's write here 0, 0, 0, 1. And now we are at this pointer, means we are at here. Now you can see we get 0, means we have to increase the counter by 1. Again we are at here and again we get 0, so increase our counter by 1. Now again we have 0, so we will increase our counter to 1. And one thing I have added that one, so I am not included here. So for that I have to include by 1. So this time, and at the end we reach at the 1, means now we are at the last position. So in this situation we have to stop. So you can see we got the we have taken six steps to make the number to 1. So this is the intuition. But main problem is, you will say, Rohit, how you add this 1 to this string, because this is a given a string and you are adding to 1. So you can see here, you can observe every time I'm going to 1, always I'm going to 1. So we have only three types of possibility. Either we are going to add something like this: 1 0, 0 1, and 1 1. These are the only three possibilities to add this one. So when we check if the string bit is 0 and our carry, so one of the cases always our carry is 1. So there is two possibility. There is two possibility only, right? There is two possibility. Either our string is look like this and our always our carry is 1. So there are two possibility, either 0 1 or 1 1. So in this situation, if we got 0 1, if we got 0 1, that means then when we add this 0 1, so there is no carry. There is no carry, it will be 1. So when I got this situation, we just replace that string value with 1. So, and when I get both is 1, then in the situation I replace with 1 and still my carry is 1. Okay, let's understand. Uh, yeah, let's understand. If suppose my string is looks like this 1011, right? And I want to add 1. This is like, let's say this is a carry. I want to add 1. So here, this is 1 and this is 1. So when I, in binary, when I am going to add 1, it will looks like 0 1. So in this situation, what we will do, we replace this bit with 0. And again, still we have carry is 1. So we move to this pointer, this pointer. And now we will check, this is 0 and my carry is 1. That means when we add 0 1, it will become 1. There is no carry. Carry will be 0 here. So we just replace 0 with 1 and rest of the bits will be same. We don't go, there is no need to go ahead. Okay. So this is the approach to add the 1 to the string, right? So let's see the solution. So what we are doing here, we first reverse the string. After that, we are taking the counter variable for counting how many changes we have done. And so we will start from 0 and string dot length. And while if suppose we are getting 0 0 1 like this, in the previous question I have discussed in this situation, so what I will do, I will move and count, because these are 0, means these are basically. So how I think right shift, left right shift. So what is the right shift? We are dividing by 1, means 2 raised to the power 1. Yeah, 2 raised this is 1, so 2 raised to the power 1. So every time we are dividing. So if we have 100, that is equivalent to 4, and when we divide it to 2, it will become 2, so it will become 10, means this bit is removed from right side. So I have shifted one bit to the right, so now our remaining part is 10. That's why we are just increasing our pointer. When we get 0, then we are going to increase our pointer and increase our counter as well. So this is the thing. So when we are at here, when we get the string index is 0, then we increase our pointer and also count the variable, because that time I'm just dividing by 2 to 2 like this. And when I reach at the last character, suppose all the zeros and only one in the last, so when reach at the end, okay, so in this situation we have to break. For that I have written this like that. And the second thing, when I get 1, when I get 1 in this situation, means we are, our first bit is 1. So in this situation what we will do, we add 1 to that string, that is part of the string, substring. So in this situation we have to increase and increase our count variable and add 1 to it. So this function increase, you can see here this function. So this is, I think, irrelevant. I have used this because carry cannot be 1, carry always be 0, but yeah, yeah, this is irrelevant, so you can avoid it. So what I'm doing here, I have that string and index where I was standing, right? So this is a very relevant thing. I'm just checking that this function is working correctly or not. So what I'm doing here, I will check, and if we check the if carry is 1 and the string is value is 0 at that index. So what we will do, just to replace with 0 with 1 and carry is equals to 0, and there is no need to go further. And else means we have 1, means our carry is 1 and our value is 1. So in this situation I will replace 0, but I'm not going to change the carry, because carry, you can see in here, carry is still 1. I'm not going to change. In this situation means we have 1 1, when we add, then carry is still 1. So that's why we go to the next bit and again check this condition, and after that at last, if we have carry 1, so in this situation we add that 0 1 to the end. So let's see this case. If suppose we have 1 1 1 and we want to add 1, so when we add 1 1, so it will become 0 and carry will 1. Again we it will we add, it will become 0 and carry is 1. Again it will become carry is 0 and sum is 0 and carry is 1. So at last we have to add this bit, right? So for that I am adding this one to the end when carry is 1, right? So this is the solution. uh, let's run and see why it's working. So it is submitted successfully. So this is the solution, you can see. So we will meet in the next video.